New York City, a skyline so iconic it's practically a global trademark. But behind this forest of glass and steel lies a long history of controversial architectural decisions, choices that reshaped neighborhoods and changed the city's character forever. Today, we're decoding NYC's most debated skyline features, from pencil-thin Supertalls to zoning loopholes, from Central Park shadows to billionaires buying slices of the sky. We're breaking down the decisions architects made, and why some people say they've ruined the city, while others say they've taken it to the next level. Stick around, because once you understand these design choices, you'll never look at New York the same way again.
In the last decade, a new species of skyscraper has taken over Manhattan, the Supertall. These buildings stretch over 300 meters into the sky, yet many of them are thinner than a pencil. Architects embraced this extreme design because it's the ultimate real estate formula. Small footprint, massive height, unbelievable profit. In the past 5 years alone, 8 super tall skyscrapers have been constructed in New York City. Perhaps the most impressive of them all is 111 West 57th Street, better known as Steinway Tower, the thinnest skyscraper on the planet, rising 1,428 feet with a mind-bending 1:24 slenderness ratio. This building redefines what modern engineering is capable of. The rise of supertalls in New York City comes down to two main reasons. First, limited land and extremely high property value. Manhattan is an island, and space is scarce, so building upward is the most profitable way to maximize floor area on small plots. Second, economic growth and luxury demand. Supertalls attract investors, corporations, and wealthy residents. Places like Billionaires Row show how panoramic views and exclusivity allow developers to charge premium prices that justify the cost of these massive towers.
To understand New York's modern skyline, you have to understand its zoning laws. In 1916, the city introduced the nation's first comprehensive zoning code, requiring tall buildings to step back as they rose. These setbacks protected light and air on the streets below, and created the iconic wedding cake silhouette seen on classics like the Empire State Building and Rockefeller Center. But everything changed in 1961. The city adopted a new zoning system focused on floor area ratio, or FAR. Instead of mandating setbacks, FAR controlled how much total floor space a building could have, not its shape. This shift allowed developers to design much taller and slimmer buildings, especially when it discovered they could buy unused air rights from neighboring properties. And in that moment, the sky literally became a marketplace. Developers stacked these purchased air rights to push towers higher and higher, enabling architects to create supertalls that were once unimaginable. Then came the shadows. As new supertalls rose along 57th Street, residents and planners began noticing long shadows extending into Central Park, particularly during the fall and winter months when the sun sits lower in the sky. Shadow studies showed that towers such as 432 Park Avenue, 111 West 57th Street, and Central Park Tower can cast shadows stretching several thousand feet across the park. These shadows are not constant, but on certain days they can last for 1 to 2 hours, affecting specific areas like open fields, playgrounds, and walking paths. Community groups express concerns about reduced sunlight, cooler temperatures in shaded zones, and potential long-term effects on vegetation. Urban planners noted that while these impacts are generally limited, they do alter how certain parts of the park feel and function during specific times of the year. Architects and developers maintain that the shadows move quickly and that the park still receives ample sunlight overall. They point out that New York's zoning laws allow these heights, and shadow impacts were evaluated during the approval process. Beyond design choices, super tall buildings also face significant engineering challenges. Because many of these towers are extremely slender, they must withstand substantial wind loads, vibrations, and structural stresses that increase with height. One of the primary solutions is the use of tuned mass dampers, large steel or concrete weights installed near the top of the building. These dampers, sometimes weighing several hundred tons, move slightly in response to wind forces. This motion helps reduce the building's sway and ensures that residents do not feel noticeable movement during storms or high winds. Despite this advanced technology, some buildings have still reported operational issues. For example, 432 Park Avenue received complaints about wind-related noises, elevator vibrations, and occasional plumbing complications, including a notable water pipe failure that affected multiple floors. These incidents highlight the complexities of maintaining extremely tall, narrow structures. A few other supertalls have also required adjustments to elevator systems and mechanical floors to better manage vertical movement. While engineers consider these challenges manageable and often expected in buildings of the scale, critics argue they illustrate the limit of pushing skyscrapers to extreme slenderness.
And that's the story behind New York's newest Supertalls. If you enjoyed this breakdown, make sure to hit the like button, subscribe, and let me know what part of the Skyline you want explored next. Thanks for watching, and I'll see you in the next video.